All right, we've got a question here dealing with finding the sampling distribution for a mean, sample mean. And the question says we've got a distribution of values that's normal and has a mean of 220 and a standard deviation of 18. From this distribution, we're going to draw a sample of size 40, and we want to find the interval containing the middle 82% of sample means. So, we expect when we take a random sample from our population, we expect that that population, the sample will have a mean that's the same as the population. But there's sampling variability. The samples don't always get exactly the same percentage that you need. So, you know, if you flip a coin 10 times, we expect to get 5 heads and 5 tails. But you don't always get exactly 5 heads and 5 tails. Sometimes there's 6 of one and 4 of the other, or 3 and 7. You know, it can vary from sample to sample. You don't always get exactly the value you expect. So we expect to get 220, but we don't always get 220. But the central limit theorem tells us that this distribution will be a normal distribution with a mean of 220, and the standard deviation of the sample means will be the population standard deviation, which is in this case 18, divided by the square root of our sample size. So that will give us the standard deviation of our sampling distribution, 18 over the square root of 40. And what we're trying to do is we're trying to find out where can you go to capture the middlemost 82%. So we're trying to find sort of what are these values here on each end where we capture 82% of the samples. We want to say that 82% of our samples will be within, whatever A to B, whatever A and B are, sort of thing. So I need to find out where those values are. But I know the mean is 220 and the standard deviation is the sigma, is this 18 over the square root of 40. And so what I want to do is I want to first say what are these two endpoints going to be. And I'm going to use my calculator and I'm going to use the inverse norm command to find the percentage that I need. Now the inverse norm always wants the percentage of values that's to the left of whatever point that you're looking at. So if I have 82% here in the middle, 82% is here in the middle, that means that I've got 18% that I haven't accounted for yet. And that 18% is going to split equally between 9% on this bottom edge and 9% on this top edge because the normal distribution is nice and symmetric. So what I need to do is I need to do inverse norm of 0.09 to find the z-score corresponding to A in there. So I'm going to start by finding the z-score that corresponds to A. And let me get to my calculator here. And inverse norm is here under the distribution menu. And inverse norm is the third one down. And it wants the percentage, 0.09. 9% as a percentage would be 0.09. Okay. If it's asking you for a mean and standard deviation, probably the way to do it to get the same value I'm getting is to put in 0 for the mean and 1 for the standard deviation. And it will spit out this value here of negative 1.34. So I want to go 1.34 standard deviations below the mean to get to that 9% cutoff. Or the normal distribution is also nice and symmetric. You can also know that that's going to be negative 1.34. That the normal distribution is nice and symmetric, that this B value should be a positive 1.34, that the A would be a negative 1.34, and the B would be a positive 1.34. Or you can do an inverse norm of, let's see, the percentage that's to the left of this point would be the 82% plus the 9% in the tail. It would be inverse norm of 91%, 0.91. And you should find that that's a positive 1.34 as well. So what I want to do is I want to take that, how about the negative 1.34? That's equal to whatever value I'm looking at, the A value that I'm looking at on my distribution, minus the mean divided by the standard deviation. And for our distribution, that's 18 over the square root of 40. And so to solve for A, I want to multiply both sides by that 18 over the square root of 40. Negative 1.34 times 18 over the square root of 40 is equal to A minus 220. And so then add 220 to both sides to find A. And so A would equal, jump back to my calculator here, would equal 220 plus, well, it's going to be actually minus 1.34 times the 18 divided by the square root of 40. And so the left side of my interval is going to be 216.18. 216.18 should be the left side of my interval. And then the right side of, or 216.19, this would be 216.19 is going to be the A value. And then the B value, I just need to change that from a minus to a plus. And here's a nice trick. If you type in something complicated in the calculator, you can do your second and then your enter button, and it will pull it back up so you can edit. And all I need to do is move up here and change this minus sign to a plus, because I want to look at that 1.34 standard deviations above the mean, and that would give us 223.81. So B would be 223.81, and so what I've got is I know that 82% of the sample means should be between 216.19 and 223.81. Or as an interval notation, we'd write that as 216.19 comma 223.81. The interval notation, we use either square brackets or curved brackets. Let's use curved brackets in this case, and say that we have to be between 216.19 and 223.18 to capture 82% of our values.